Good afternoon, and welcome to today's edition of Fast Fluids. Our topic today is submarines. Originally invented in 1620, they have undergone drastic design changes in order to become the effective anti-ship weapon we see today. But how do they work? And what must we take into account during their design process? Let's dive in. For starters, submarines have two distinct hulls. The outer hull houses the ballast tank and other necessary equipment. It is designed with a teardrop shape in order to improve surface navigation. Then comes the inner hull, or pressure hull. It is made out of thick steel in order to protect the sub's crew from the crushing weight of the water around them. Precision is of utmost importance during the design process, as being only 1 inch off in terms of thickness can reduce the hull strength by 30%. Before we go any further, we need to introduce the concept of density. Density is the amount of mass an object has relative to its volume and is an intrinsic property of a physical object. An object with low density, for example this empty plastic water bottle, will float, whereas an object with higher density, such as the same bottle filled with rocks, will sink. Now, let's talk about the ballast tanks. Originally patented in 1747, and at the time were basically gigantic leather sacks, the concept of the ballast tank can be seen in a variety of forms of aquatic life, such as the blowfish. How the tank operates is relatively simple. The tank will either allow the seawater to flood in or use compressed air to push the water out, replacing it with the air, thus regulating the submarine's buoyancy. Buoyancy is the upward force that determines whether an object will float or sink, and is primarily due to the water pressure on the submarine. In order to calculate the buoyancy force, you must take the density of the fluid, in this case seawater, and multiply it by the volume of the submarine and the acceleration due to gravity, or simply B equals rho times V times G. It is important to note that while buoyancy is acting upward, the force due to gravity is still acting downward on the submarine. This interaction leads to 3 types of buoyancies. When the buoyancy force is greater than the force due to gravity, the submarine experiences positive buoyancy, or floating. When the forces are equal, the submarine experiences neutral buoyancy and stays at the same depth. And finally, when the buoyancy force is less than the force due to gravity, it experiences negative buoyancy, or sinking. Lastly, a crucial thing to consider during submarine design is the point of application of these two forces. The buoyancy force will be applied at the center of the submarine no matter what, but the weight must be applied below it in order to ensure the vessel's stability.